Our next presenter comes from Mason, Ohio. Please welcome Piyush Shrivastava of Genetesis.
All right, so good morning, ladies and gentlemen. My name is Piyush Shrivastava. I'm founder and CEO of Genetesis. But before I begin my presentation, I'd like to share with you a personal story. So in 2006, my grandfather was diagnosed with a wealth of different conditions, ranging from cardiac rhythm disorders all the way up to Alzheimer's, bipolar, Parkinson's disease. And what we found was that every time he was given a new drug, there was a new adverse impact on his heart, whether or not the drug was meant to impact the heart. And that introduces the problem that Genetesis is trying to solve. Genetesis is in the business of saving lives. And the first type of lives we're going to try to save are those patients who are suffering from cardiac rhythm disorders. Atrial fibrillation alone affects 2.5 million patients in the United States. And current treatments and treatment methodologies even are completely flawed. Physicians recognize it, the FDA recognizes it, but most importantly, now the patients are seeing the adverse impact of that. And the reason is simple. Current solutions lack relevant data generation. The EKG has remained unchanged since 1909, and it's archaic. Think of what Genetesis is attempting to do as similar to what we saw with the car diagnostic market. In the old days, they would use a timing light and run a voltmeter all around the car to try to identify where's the problem. What the EKG does, and what we're doing to the EKG, is similar to the new innovations we see, where you have a plug-and-play system into the car, and you generate a wealth of information at the touch of a button, automated processes. FDA, biopharma, and the clinics see the value in our opportunity. Looking at the problem from a more pictorial standpoint, you have here a biopharma representation of what we're doing. Both of these mice have the same heart rhythm condition, long QT syndrome 3. And we see the EKG validates that. Yeah, they both have the same condition. So, thereby we give them the same medication. But the responsiveness is completely different. One mouse is rescued, the other dies. It's dramatic, but it's how it works. Looking at human data, this is an example of warfarin. From one ethnicity to the other, responsiveness is completely different, but even within ethnicities. And we can see that it's the same for beta blockers and really any type of cardiac rhythm drug. There's no outlier here. Looking at the numbers, sometimes numbers speak louder than words. And in this case, numbers are screaming for change. Looking at the increase in total charges caused by adverse drug reactions, specifically in the cardiac space, $516 million. But that's not for the United States population. That's for 740 patients isolated by the World Health Organization over the course of 16 months. So imagine what the United States at large is facing. Here's where the Genetesis solution plugs in. It's as simple as you have the same scenario. Both of these mice have the same condition. EKG shows that. But in supplementing that EKG, we create unique ion profiles for both of these animals. And that's done through software and hardware, as you'll see on the next slide. But we generate these unique ion profiles, and we find that different medications are given, and thus we secure a rescue for both mice. Looking at the actual product package, we're selling hardware, a software analysis platform that's well-tailored to different market segments, both from a price model and a deliverable standpoint. We're also providing proprietary database information for biopharma developers, as well as expert consultation from our on-site cardiac team, whether it be interpretation of our data as output, which is actually very similar to what the physician's already dealing with. It's minimally disruptive to how the patient and the physician work together. And we can also provide expert consultation with regards to training, whatever minimal training would be needed. Looking here, our team is incredibly well positioned to incorporate our technology right into the EMR for hospitals. Whether it be healthcare administration, business, science, or physicians, we've got all of them on our team. And this is exactly what the software input would look like within the EMR. As you can see by these other tabs, this is exactly what it would look like on the HL7 standard. So we've definitely visualized what our product looks like, and we started developing. With regards to the business model, we've made this very structured and sequential. It's a logical model. Starting from early validation with the biopharma market, we can see that this would be an early traction model where biopharma hasn't been able to push out a new cardiac antiarrhythmic agent, an agent meant to control the rhythm of the heart, in the last 12 years. For heart failure, that number is 25 years. The Genetesis solution will be able to cut biopharma's development time in 12 months, and generate a lot more data that will show efficaciousness of their drug in the market. And we'd be able to generate that data both for animals as well as patients. But at the end of the day, once again, Genetesis is all about the business of saving lives. So the clinical decision support system in the clinical long term, which is in fact not so long term, as early as 2019, will be able to have our system incorporated as a clinical decision support system in diagnostic procedures. Just simply understanding from the physician standpoint, which drug is most ideal for the individual I'm looking at right now, considering the fact that my EKG readings aren't going to give me the most individualistic recordings of this patient. And what you may be wondering is, how do you scale to these completely two different markets? The scalable model that we have right here is a series of IRB studies that we've already talked about with several people at Ohio State, as well as the University of Buffalo. We've already generated a lot of value here, and we're talking about how can we take our biopharma model and get it on patients before we take it to the clinic and get our FDA approvals. So we have a series of models that we've prepared for that, just to show how serious we are about that clinical long-term market. With regards to market impact, once again, huge market, $1.8 billion per drug. You can imagine the cost savings by saving biopharma companies 12 months on average for developing their drugs and generating that relevant data. And once again, that clinical hospital system market is very important to us. There's a lot more than 28,000 prospective buyers there. That's just the early adoption of clinical opportunity. So those would be university hospitals that we've already talked to and such. But the competitive landscape is really incentivizing for what we're doing. Companies that are local here, iCardiac has generated a very successful model, and Cardio Insight, which generates a very complementary model, after raising over $25 million relatively quickly with, I think, a $20 million Series B, they're already in acquisition talks. And that validates the fact that the EKG is moving towards a space where you have to start analyzing novel signals. And that's exactly what Genetesis does. And the amazing thing about what we do is we incorporate those competitive business models, but we incorporate our advantage by making our processes more automated, by making our processes very minimally disruptive to how a physician is interfacing with their patient. There's no really fundamental change to this hardware. The only change is what the physician doesn't see, and that's what they want. From a standpoint of revenue streams, once again, it's complementary to that business strategy where we've got the revenue models from iCardiac, as well as the Cardio Insight revenue model for the clinical applications. And the financial projections complement that beautifully. We're looking at clinical adoption as early as 2019, biopharma adoption at 2017 after talking to 20 cemented biopharma companies. With regards to Genetesis scalability, we've already generated a lot of excitement in the venture capital industry at Ohio, in due diligence with several Ohio firms. But what's more important to us is to partner with someone who's looking towards that long-term clinical future. Just a few days in Buffalo has proven to us that $1.2 million should be raised here, because here in Buffalo, they're more excited about that clinical opportunity, and they are also in the business of saving lives. With regards to upcoming milestones, that $1.2 million, we've already generated some of those milestones with a very minor amount of funding that we put in ourselves. But we're also expecting the alpha product release in mid-2015. That would be a working prototype that would actually be ready for scaling to clinic with those IRB studies with the universities. Our team is incredibly well positioned to bring this product to market, mainly because we're a mix of intuitive minds, intuitive thinkers, as well as the scientists and physicians who have already validated this kind of technology. From a standpoint of our advisors have already done this before, whether it be in biopharma, creating cardiac drugs and making them a market value and actually getting them into the market, having really successful exits in their spaces. They've joined our team now very early on, knowing that this is the way we're going to be making our future better and actually getting involved in that business of saving lives. With regards to creating strategic partnerships right here in Buffalo, it doesn't take long for us to do that. We have 12 members on our team right now. We've been operational a year. Imagine what we're going to do in Buffalo with the resources that we've already begun talking to, whether it be Great Batch Medical, whether it be the University of Buffalo School of Medicine, or the CBLS. We've talked to them all, and we're very excited that UB is going to be supporting us and that the city of Buffalo has already been so supportive of us. Thank you so much.
I don't want to bias this. Have you turned 19 yet?
About to.
He's 18 years old, ladies and gentlemen. 18 years old. Wow. Okay. Bijan, you got a smile on your face, so you're sitting here looking at the future Mark Zuckerberg or something, it sounds like, right? Huh?
Hit me with it.
You let him get out of Boston, maybe we can't let him get out of Buffalo.
Did you finish college?
No. Idea's hot.
All right.
I'll be taking a leave of absence from Ohio State University right now, studying biomedical science.
Well, I love the inspiration. I mean, oftentimes we find the best founders are inspired to build things with personal life experiences, and it sounds like it's certainly the case here. One piece I really didn't quite follow. So you're interfacing with existing systems, and then the real core intellectual property is this database and signal analysis system that you built.
Right.
And so what's the underlying algorithm behind that? I mean, like, how does it actually, like, what's the secret sauce that you've built in that system?
Absolutely. So the EKG is a very small signal. It's really difficult to detect, and there's a lot of invasive media. You got the lungs right there and whatnot. So our signal, and really our proprietary sauce, came out of the research world. They have a research-based algorithm that's used to quantify how active ions are at a cellular level. Well, we said, all right, that algorithm's really helpful to us. Why isn't it used in clinical application? It has no units. There's no standardization. There's no clinical relevance. We created all of that. We re-derived the algorithms. We talked to our advisors. They said, this is it. We got it. We transformed that into a signal detection system and said, look, all you really need to do with the hardware is get this licensed to someone like GE. They're already the world's largest, they have the most market share. Between them and Philips, they own 60% share of the ECG market. So they already have the manufacturing down. Why don't you just add your system to that existing EKG system? Give physicians a choice. You can use the EKG system, or you can use the Genetesis system. The issue is, someone who uses the Genetesis system, they're going to inspire their patients to go talk to other physicians and say, are you on the Genetesis system? And if you're not, tough luck. Physician isn't going to be getting a lot of patients.
But what I don't quite understand still is your system detecting, is it simply analyzing the EKG better, or what is it actually detecting, number one? And then number two, if I know these two patients are different, I still need to know which drug is better for the other. And so you're going to have to be doing a lot of, it's just like genetics. It's one thing to know somebody's DNA, but knowing what the DNA means in practice, you need lots of patients and lots of studies and lots of examples of what works and what doesn't.
Absolutely. So to start, the signal is not actually a build-off of the EKG. It's more similar to some applications in the research world. And the issue with that, though, is that the signal is so powerful that it also gives us the ability to recognize what is the pharmacology of this drug going to look like. So they have that really well-founded in the research world. The issue is you can't detect that signal in the clinical world, at least not how it was. We've transformed that signal. The signal is the aggregate signal of ions. So we measure really the flux of sodium, potassium, and calcium. We quantify those fluxes, and we say, look, we understand the electrophysiology of those ions, and we know the pharmacology of those drugs. We can profile the match and create like a profile saying, here's how efficacious this drug would be for this patient based off their unique real-time ion profile.
Yeah, I'm still getting the same dose as somebody twice my size. Medicine is very slow to adopt even sensible technology.
Right.
David.
Yes, I'm having a little trouble understanding how we've gotten from the concept of ion flux to some of the statements that you're making, to the conclusions that are being drawn. Particularly when if I heard you correctly, you said that you'll have a working prototype in 2015. So without a working prototype, how do we know that we know what we're saying we know?
Okay, so we know we're measuring this aggregate signal, right? And
But
we
how?
how are we?
What technology are you using as a detection system and an analytic system in humans?
Got it. So if you're asking specifically about the device,
Yes.
so the way we have this layout with the patient is essentially a non-invasive sensor array. It's a group of macro electrodes that are positioned pretty strategically throughout the body. And the amazing thing is that we can differentiate these ion fluxes as tensors. They have these very unique spatial movements. And that enables us to say, all right, we're looking at this tensor movement right now, so we can null out all of the other recordings. In other words, we know we're looking at sodium, everything else reads null on the electrodes, and that's how we essentially filter out which ions we're recording.
And what are the sensors reading into that give you that ion output?
Right, so one of our advisors, he is just one of our most recent advisors, is Jason Heichenfeld. His specialty is in flexible circuitry, and he analyzes sweat microfluidics. So using those sweat glands, you can measure the ion flux on a very aggregate level, and that's essentially what we're collecting, is the ion flux of those aggregate signals.
Thank you.
Is there any role of the physician or the doctor administering? Is it just meaning a readout, or is there any way for him to manipulate what kind of data that he wants?
So, like I was saying, when the physician is interfacing with the patient is all that matters. They want a really minimally disruptive way to interface with their patient. So what we've done is made this mostly a decision support system where we supplement what they have with the EKG and let them handle most of the interpretation. What we do is we try to make it as easy as possible.
So it's the same information every time for every physician, for every time they do an EKG, it's the same information as how the doctor wants to interpret it for
Right.
his patient. Okay.
Any other questions? Are we going to put this on? Any other questions? Hold on, I don't want you to leave. Is this your family over? Is this your father with the camera? Huh? I want to talk to you for a minute. What do you think of your son's presentation?
It was excellent in there. And I have seen him presenting for the last 3-4 years, and he has grown better every time he presents there.
How does he do compared to you?
Much better, and that is what I wanted.
You must be a very proud father today, huh?
I am.
Yeah, and what are we going to do? If we got him to come to Buffalo. I don't know if he can cross state lines at that age and live here, huh? What are we going to do?
So we are relocating. Basically, we are coming over to Buffalo along with my wife and my daughter.
Oh, the whole family, the daughter, the sister has to come, huh? Are you looking forward? How old are you?
I'm 14,
14, what grade?
8th grade.
8th grade. Oh, we have great high schools here. It's a great place to grow up, and we look forward to having you on this stage too one day, but good luck to you. You should be proud of your brother, huh?
Maybe by the time she's 17.
yeah, right. Maybe we'll get it by 17.
She's not allowed to beat me.
David, you have another question?
Yeah, I had one other question, a business and sort of strategic question. You have migrated to Jensen Labs in New Jersey, and how would that affect a further migration to Buffalo?
Absolutely. So the Janssen Labs facility is actually in South San Francisco.
Oh, okay.
Yeah, so we have a small facility, and the amazing thing about that is it's basic research. It's actually generating more value here in Buffalo because we have the ability to generate a small amount of data, basic science data over there, which means we need a lot more people here to be generating clinical grade data. That data is simply, all right, we need to validate and have a feasible platform. That's just a small amount of data generation that goes around there. But over here, that's where we're generating real value.
And that facility stays there, it doesn't migrate with you?
It's actually like it's their own facility over there. Their facility also has the Johnson & Johnson Development Corporation. So we're housed within there. It's like a small incubator space of its own. And I was talking to Andrew Polkerback, and we have the option to move wet lab space here as well. So if that's an option for us, we're going to take it. Whether or not that facility is working out well, we want to do everything here in Buffalo and have an entire translational solution.
Great. Piyush, great job. Thank you very much.
Yes, sir.